I would like to officially welcome you to AgentPro's course on Value Stream Mapping. To start with, we recommend that you watch our courses on Lean Principles Process Mapping, Lean Principles, 3M and the 7 Deadly Sins. Both these courses will prepare you to fully understand value stream mapping. Let's begin with an overview of the things you will learn by the end of this course. First, the prerequisite. As mentioned, this course has 2 prerequisites, process mapping and lean wastes. Next, by the end of this course you will know what is a value stream and value stream maps, why value stream maps are so useful. You will also learn the process of creating a value stream map. You will learn all the metrics, symbols and protocols involved in making a value stream map. You will also get an introduction to lean in the service industry. This course will have a follow-up which will be a live sample case study, targeted on the BPO industry. Finally, you will learn how to create action plans. We will begin with what Womack and Jones stated are the 5 principles that are needed for value stream mapping. The first principle is defining the value. It is capability provided to customer at the right time, at an appropriate price, as defined in each case by the customer. Second principle is value stream, and is defined as specific activities required to design, order, and provide a specific product, from concept to launch, order to delivery, and raw materials into the hands of the customer. The third principle is creating a value stream, which means progressive achievement of tasks along the flow, so that a product proceeds from design to launch, order to delivery and raw materials into the hands of the customer, with no stoppages, scrap, or backflows. The fourth principle is pull system, which is defined as system of cascading production and delivery instructions from downstream to upstream, in which nothing is produced by the upstream supplier until the downstream customer signals a need. Last principle is the target of complete elimination of waste, so that all activities along a value stream create value. Let's answer the question. What is a value stream? We formally define a value stream as all the steps, both value-added and non-value-added, required to take a product or service, from raw material to the customer. The value stream starts with the trigger and ends when the value has been finally delivered. The trigger for a value stream can be a customer order, an upgrade request, or an internal request. What does a value stream contain? It contains the people who work, the systems or procedures that are developed, the flow of materials and most importantly the flow of information. Some of the most common, industry-agnostic examples of value streams are the overall request for fulfillment, namely the material and information flow, from the initial customer request to the moment we collect the payment. This call-to-cash value stream applies to just about any industry. Another example of a value stream is the cycle from the time an idea for a new product or service, from when it is first conceptualized internally, to the time the product or service is produced and launched. The different types of value streams. In an organization, there are countless streams which can create value. However, all these value streams can be classified into 3 broad categories. First, product value stream. This is a revenue-generating stream. These are the steps taken to provide goods or services to the customer. Second is the R&D value stream, or the research and development value stream. These are the steps taken to build capability, research and develop new products or systems. This stream at times can be considered as a support stream or as a product stream if the organization is structured differently. Finally, support value streams. These are the value streams which support the smooth functioning of operations, for example, hiring, HR, accounts, IT. Let's understand these with the help of a few examples. Product value stream. The picture shows a sales cycle. The steps, or the value stream which lead from prospecting the customer to customer checkout are indicated. This becomes the product value stream. Research and development value stream. As shown in the example, an idea is conceptualized within the organization. This acts as the trigger, instead of a customer request. Then, the feature list of the product is finalized, followed by approvals, development and testing and finally deployment and given to the customer. This kind of a flow is called research and development value stream. Support value stream. The example shown is of a customer request for a loan in a banking organization. After initial form filling and profile creation, the request is sent to headquarters for loan approval. All the steps there take around 1.5 hours. These steps form part of support value stream. Before we dive into creating a VSM, we should spend some time on why we use value stream maps. VSMs visually help us see the overall process, and not just a single process. They truly provide a holistic view of the way things really work, and they also allow us to see things from the customer's perspective, be it external or internal. They help us quickly identify wastes in the process, in other departments, and in the enterprise. Finally, they help us focus on the linkages between materials and information, and provide us with metrics and KPIs to improve upon. There are similarities between a value stream map and a traditional process or flow map, but there are some major differences. The most striking difference is that value stream maps focus on both material and information flow, while many flowcharts show material flow, but completely leave out the information. As was mentioned earlier, a VSM provides a lot of KPIs to improve upon. We will discuss KPIs which have been modified to make them pertinent to the BPO industry. All these KPIs, which will be used in making a VSM, are discussed in detail in the next few minutes. The first is process time. It is the total time it takes to complete a task. The total time includes the entire time, including pre-processing, processing and post-processing time. To understand with an example, the process time for an inbound call would include talk time, hold time and after call work. However, it will not include wait time in the queue, ring time or any aux time. Lead time. Lead time is the total time from when the work is provided, till it is completed and passed on to the next activity cycle. Note that the lead time includes both the process time and the wait time. For example, the lead time for an inbound call would be VDN time for the customer, queue wait time, ring time, talk time, hold and ACW. If the call is further transferred to another queue, the wait time for transfer will not be part of the lead time for that inbound call. Complete and accurate percentage or CA%. It is the percentage of output work that is considered complete and accurate. For example, in a tech support process, when a complete and accurate resolution is given on a call, its CA percentage is considered 100%. Or in other words, the FCR of a tech support rep will be considered their CA%. Because all FCR calls will not require any rework. Another example. In a back-office process, a rep receives 100 claims to be processed. However, upon checking for accuracy of information, 28% are sent back due to incomplete information. The CA% of the received claims is 72%, because only 72% claims can be worked upon without first checking for accuracy and completeness. The next metric is a handful. It is called rolled first pass throughput yield. The rolled first pass throughput yield can be thought of as the end-to-end first pass resolution rate of the process as a whole. It is the final percentage of work which does not require any rework. To arrive at this value, the CA% of each step is multiplied. For an example, let's consider a telco tech support process. Let's assume that the customer has to first call customer service, then is routed to tech support, and finally ends up in billing. If customer service has an FCR of 75%, tech support is at 80% and billing is at 90%, then the final RFPTY will be 75% multiplied by 80% multiplied by 90% equals to 54%. This can be read to mean that despite very high FCR or CA% numbers by each department, only about half the customers can expect their issues to be resolved in the first instance. The inference clearly would be to make a change in the structure of providing resolution to the customer. Activity ratio, as the name suggests, is the percentage of time in which work is being done. This work can be a value-adding work or a non-value-adding work. Activity ratio is equal to sum of process time divided by the lead time, hence, 1 minus activity ratio is equal to the idle time. For example, a customer calls in an inbound queue. Below are the metrics of the queue at that given instance. Queue wait time is equal to 100 seconds, average ring time is equal to 10 seconds, AHT is equal to 10 minutes or 600 seconds, including hold and ACW. The activity ratio will be AHT divided by queue wait time plus average ring time plus AHT. Or 600 divided by 100 plus 10 plus 600 equal to 84%. In different processes, activity ratio is also termed as productivity percent or occupancy percent. FTE or full-time equivalent is a measure of the number of productive hours that will be required in a given year. To calculate an FTE, we first calculate the number of hours available in a year, per employee. The total number of days in a year is equal to 365. The total number of weekly offs is 104. Then we assume the maximum leaves that an employee can take. Here we say it is 32. After removing the maximum leaves and weekly offs, we arrive at the total working days as 229. With 8 working hours in a day, this gives us 1832 net working hours in a year. From the net working hours in a year per employee, we then estimate how many full-time employees will it take to get the work done. Now let's consider an example which will show how this metric is useful. Say, a client wants to give a business of 100,000 calls per month, with the AHT of each call being 10 minutes or 600 seconds. To arrive at the first base level of FTEs, we multiply the number of calls per year, with the AHT, and then divide this by 1832, which was the net working hours. Then we arrive at a base FTE requirement of 110 people. Now to this, factors of attrition, shrinkage, occupancy, shift influx etc. will be added to arrive at a final FTE number. However, the work can be estimated to have a base FTE requirement of 110 people. So, the client and the vendor can agree that the work will be for 110 full-time employees. This will then help in working out other terms of the agreement. In this section we will learn about the various symbols used in making a VSM. This first symbol represents a supplier or a customer, both of whom are entities outside the organization. The process block is a placeholder for an activity or task. The data block, as shown, shows all relevant KPIs. WIP. This symbol is used to show work in progress. The symbols for electronic flow of information and manual flow of information are different. The right arrow denotes manual shipments. This is the symbol for an employee. It also denotes the number of employees it takes to complete a task. Push arrow and logistics symbols are as shown. Finally, the lead and process times are marked below each activity and also as a summary. Guidelines for creating a VSM. The first step is creating a project charter. In a project charter, clearly identify the internal and external customers and the customer requirements. The project charter should also have clearly marked triggers, final goals, stakeholders and timelines. The champion, sponsor, VSM manager and team members should be clearly identified. Next, make an as-is VSM. Capture the process as it operates at this moment, not how it was originally designed to operate or how it should operate. Assign a value stream map manager to lead, and finally, make a future state VSM, as-is map. Customer and supplier must be clearly marked. Each block of activity has to match with the timeline below. Include the number of employees. Include obstacles to flow. All data blocks must have key metrics PT, LT, %C.A. These should be summarized in the end. Finally, identify all VA and NVA steps. Future state map. Remove all flow obstacle, or, remove all wastes, which are, WIP, rework, handovers, motion, inventory. Next, ensure load leveling to tackle MORA. Plan on removing multiple decision-making points, create pull in the system, plan to implement Kanban, standardize work. Next, create a KPI benefits table. Create a future state action plan document to be owned by the VSM manager. At this point in the course, there has been a lot of information that needs to be assimilated and internalized. I recommend that everyone should pause and go through all the topics discussed till now once again, to ensure proper understanding. For the next step, which is making a VSM, we will use a live case study to be done as a follow-up course. Up next are just visuals of project charter, as-is VSM, future VSM and action plan. In the follow-up course, we will do a VSM study of a live project. We will make a project charter, KPI tables, as-is map, future state map and finally action plan for implementation.